Hello guys, welcome to Optimize a Step, where we teach concepts of AI and ML step by step. So in the last video, we completed our AI ML laptop setup. We installed Python, Miniconda, VS Code, and Jupyter Notebook. So now the setup is completely ready for our AI ML coding. So what should we learn first? This is the first question that we should ask ourselves. The answer to that is Python. But many of them usually ask this question. So, but why Python? Why is Python chosen for AI and machine learning? There are many other programming languages like Java, C++, JavaScript, and R. But Python became the most popular language for AI and ML because it is simple, readable, and beginner friendly. So when we are learning AI and machine learning, our main focus should not be fighting with the complicated syntax. Our focus should be understanding the data, the logic, the mathematics, models, and its predictions. Python helps us do that because the code looks almost like English. Now, another big reason for why we choose Python for AI and ML is the Python ecosystem. If you want to draw parallels, you can think of it like Apple ecosystem, right? Once we are logged into that ecosystem, it's really hard to get out of it. So that is also one of the reasons why people choose Python for AI and ML. So almost all important AI ML libraries are available in Python. The most famous being NumPy for numerical calculations, Pandas for data analysis, Matplotlib for visualization, scikit-learn for traditional machine learning, and later PyTorch and TensorFlow for deep learning. So when we learn Python, we are not just learning a programming language. We are learning the main tool that helps us work with data, build machine learning models, and understand AI practically. So in this video, I'm not going to teach complete Python. That is not needed on day one. Today, we are going to make the first step towards Python coding. Today, we are going to learn only the Python basics that are important for ANML beginners. We'll start with very basic print function. Then we will do the variables, data types, math operations, lists, if-else conditions, loops, functions, and finally, we will use pandas to work with a small data set. By the end of this video, you will write your first Python notebook for AML. So let's begin. So in the last video, we have already discussed how to open a Jupyter notebook. For AI and ML, this notebook is very useful where we can write explanation, code, and output in the same place. So usually what happens is when we start with a machine learning project, we experiment with the data. Okay, we do not start writing modular codes for the project. So first we experiment with the data. We find out if there is any issues which we need to resolve, and over here we can do that in Jupyter Notebook. Okay, so now there are two types of cells. You will see two types of cells here. First is the coding part where you write your codes. Now there is one more thing called as markdown. So in markdown, you can write your explanations. For example, this is a Jupyter. So this is not your code. This is your explanation cells. So here you can write your text directly. Run a code cell, click in the inside the cell and press Shift plus Enter. So I'll show you. Print. See, so when you click Shift and Enter, your code runs in the Jupyter Notebook. So, and there is also one disclaimer. Don't worry about memorizing everything. You cannot memorize everything today itself. The goal is simple: to run the code, observe the output, change small things, and run it again. So, okay, now we'll get started with the coding part. Now let us write our first Python code. The first function we are going to learn is the print function. In simple words, print is used to show output on the screen. When we are beginners, we use print to check whether our code is working or not. But later, when we are writing our AI and machine learning codes, we use print function to check data, uh, inspect values, and debug errors, and understand what is happening inside our programs. So even though this looks very simple, it is one of the most useful function in Python. So here I'm writing a print function, and we open quotes and we write hello. Now to execute this code cell, we need to press shift and enter, and the output is hello world. So basically, whatever is inside the double quotes, the print function treats it as a text, or in Python language, it's called as a string. This string is given as an output. I'm printing a sentence related to our course. So I am learning AI ML optimizer step. So see, so whatever is inside the double quotes, Python treats it as a string and it just prints it out. Now let us print a number. Let's see what happens. So if I print, it just gives us here, no. So here I did not use quotes because 100 is a number. It's not a string. It's not a text. So 100 is a number. So I do not need to use double quotes over here. If I write 100 without double quotes, Python will treat it as a number. If I write 100 with inside the double quotes, Python will treat it as a text, or simply put, string. So if I print 100, so the output remains the same, but the type is different. This distinction becomes important later when we work with data, because numbers can be used for calculation. Numbers on numbers we can do mathematical functions, but on text we cannot directly use it for mathematical operations. So this distinction is very important. Now we can also print calculations inside the print function. For example, let's say I write 100 plus 5. So since we wrote this outside without any double quotes, the Python took these two values as numbers and did mathematical calculations on it. So, but if we put these two values, 100 and 5, inside the double quote, it gives us a value of 1005. So here comes the distinction. Strings, when they are added, they get concatenated. But if these are two numbers, they are added. So then also print multiple values together by separating them with commas. So for example, let's say Python useful for AI ML. Here Python prints both parts together with a space in between. This is helpful when we want to combine text and values, or texts and variables. So if you put in a comma in between, even then the print function prints them together. Variable is a labeled box where you can put any values inside that box. Okay, is equal to 20. Now, so what happened over here is a is a variable and we have fed it with a integer of 20. So if I print and I only say a, then it gives me 20. So basically a becomes a variable where the value of 20 is stored inside it. So, and you can store whatever you want. Let's say you want to store city name Hyderabad. Now if I print, so it prints out Hyderabad. So you can store anything, an integer, a text. It can be anything. 3.14. Now print. So C is a variable and 3.14 was the value. So this is how we store values into a variable. Do one more thing. Name is equal to, let's say, Vishal. Age is equal to 28. Now if I print, my name is name. I am age years old. So what I did over here is I combined the concepts of print and also variables. So what we did over here is we have already discussed that whatever is inside these double quotes, Python will always treat them as strings or texts, and whatever is outside are usually considered to be the variables. So here name is a variable, so it has printed out that variable's value, and age is a value is a variable and which has given us the 28 value. Okay, so remember one thing, that equal to is kind of assigning the value, not that equal to symbol that we usually use in maths. Okay, so this equal to assigns whatever value you have fed to the variable. Now the mostly used three kinds of values are string, which we also call as a text. Int are usually the whole numbers like 1 2 3 4 5 etc. Now, and float is a decimal number like 3.14. Okay, so these are the usual kinds of values that we find in Python. Okay, now you can also try to find out the kind of value by using a special function called as type. So what do I mean by that? Let's say you want to find the type of this. What is this hello? So as you use the type function, the Python tries to understand what kind of value it is, and it gives out that values type. Okay, so basically, if you enter, let's say if you enter 32, it gives out as int. Okay, so it gives out int. So as it was a whole number, it has given out as a as it is a whole number, the kind of value is int. The type of value is int. Now, if you type 3.14, it is a float. So these are the kind of values that we find in Python. So till now we have seen a variable being assigned a single value. It is either a string or an int or a float. Now let's suppose I want a variable which can hold multiple values, and the answer to that is list. Okay, let's say you have temperatures and you need to fetch in different temperatures of a particular day. So let's say, so let's say we have created a list. So temperature becomes a list, okay, because it is holding multiple values at once. So let's print this temperature string. So it gives out all the values inside it. Now, let's say we can also find out what type it is. So this is called a list. See? Okay. Now let's say I only want the second value inside the list. So how do we pull that out? So let's see. So when so the second value, I need to enter 1. Now, very important point over here. Python counting starts from 0. This you have to be very careful about. So whenever you start a counting, so let's say this is the list. Now in over here, the list 22.5. If I want to pull this number out over here, I need to put in 0. So once you put in 0, you'll get the first value. So the Python counting starts from 0. Counting always starts from 0. Okay. Now if I want the second value of from these temperatures, I will put in 24.1. Now if I want the second value from the temperatures, I will put in 1 over here. So this is called as indexing. Okay. So this value 0, 1, 2, 3, and 4. Okay. This is the index values of these numbers. So now we will discuss about making decisions with if statements. So let's suppose you have exam and the exam passing marks is 50. Okay. Now, if you score above 50, you pass. If you score below 50, you fail. Very simple. But how do we build a code for that? Very simple. Let's put the same thing in code. Let's say your score was 78. Okay. Now, how will we write the if statement? So first we say if score greater than 50, print pass, else print fail. Okay. So what is happening over here? I know the score is 78. Okay. And I also know that the passing marks is 50. So if your marks is greater than 50, if the score is greater than 50, print you have passed. Else, if this is not the condition, then print fail. Very simple, right? The only thing that you need to observe over here is this colon. Okay, this is used for indentation. Python is very strict on indentation. If you miss the indentation, the whole code will not run. Okay, so this indentation is very important in Python, especially. Okay, now once you run this code, what can we expect? Let's see. It is printing as passed. Reason is that the score is 78, which is greater than 50. So this is how we use if statements. Okay. Now let's say your score was less than 50. So for example, let's say the score was 40. Now what can we expect the output to be? Obviously, fail. Since the marks he scored is less than 50, so the print value will be fail, right? Now, the next thing that we are going to learn is repeating work with for loops. What do Let's take the previous example where we have temperatures. Now, if I want to pull out all the individual values from temperatures, it is going to take a lot of time. Over here, we only have 4 values, but let's say the list contains thousands and thousands of values. Okay, so but then how do we do that? Because we cannot enter temperature 0, 1, temperature 1, temperature 2. If we start using this indexing method, we are going to take a lot of time. Okay, so what is the workaround for it? So here comes the for loops magic. So let's say you want individual values from the temperatures. Okay, so we will write this as for temp in temperatures. Now look at this. So it gave me all the individual values in the list. Okay, so we can also build up results as we go. What do I mean by that? So let's say I want the total sum of all the individual temperature values. Okay, so what we do? So the total, let's say we take another variable total. This I will In this, I'll put in the value of 0. Now, for temp in temperatures, total is equal to total plus temp. So what is happening over here? So first of all, we took the total as 0. Okay. Now individually, so what happens over here is first the value of 22.5 total value is 0. Now in 0, total value is 0. In 0, you get 0 plus 22.5. That becomes your new total. Okay. Then the loop gets completed and next again the same loop starts. Again, the value 24.1. Now the total value is 22.5 and the temperature value is 24.1. These two gets added and is assigned to total. This happens again and again till the last value of 21.6 and we get the total of all the temperatures. So this is how the for loops works. What do I mean by this? Wrapping your logic in a function. Let's say you have a function which you are using in a particular scenario. Now you require that function again and again for different variables. Then how you are going to do that? You cannot write the whole code again and again, right? So how do we do that? So for that, we can build functions in Python. So it's like a reusable recipe used again and again for the same work. Okay, let's start with a very simple one. Define. So for that, we start the code with def. So define average of numbers. So average is the function. Okay, we are defining a function named as average, and inside that average we have different numbers and colon that you need to remember. So what does this function return? This function return sum of numbers divided by len of numbers. Right. Now, what do we mean by sum? So sum is an inbuilt Python function. Okay, just like what we are defining this average right now, Python might have one definition for sum as well. Okay, so sum is a predefined function in Python. Okay, now what is len? Len defines the number of elements in that. It can be either list or it can be either a single value. For example, if I type in over here print len of temperatures, this gives me 5. Okay, so 5, there are 5 elements inside this, 1 2 3 4 and 5. So this gives the total number of elements inside a given list, total number of values inside a given list. Okay, so if you do sum of numbers by len of numbers, you'll obviously get the average. Okay, basically what is happening over here is sum will add up all these values and len will give total number of values 1 2 3 4 5. That is how we calculate the average, right? So if we try this on, sorry, my bad, system glitches. Okay, so what it did is what happened over here is we have a function called as average that we have just now created, and we use that average function on temperatures. Okay, so instead of numbers over here, we use temperatures. So now temperatures, the total, it found the total of temperatures as well as the number of elements in that temperatures, and it gave me the average. So this is how we wrap a logic in a function. Okay, now this average can be used any number of times. Okay, if you want to use it for some other list, you can do that as well. Okay, now we are stepping into the data science part. Okay, so over here we'll play around with data. Okay, so basically pandas is used for tabular data. Okay, whenever you have, mostly it is used for tabular data, and the most important thing is pandas are built up on numpy. Okay, so numpy is another library which does numerical calculations. Okay, fast numerical calculations. So pandas is where we use tabular functions. This is the single most used tool in data science and ML. So how do we import pandas? So for that, we write import pandas as PD. This is PD. So PD is usually the acronym given for pandas, and it's a usual practice. Okay, so we cannot write every time pandas, pandas, pandas everywhere in our workflow, right? So we use a shorter term, PD. Now, once you have imported your pandas, you can check the version of pandas. Pandas dot system underscore version. Sorry, my bad. I should have used pd.1. Yeah. So since we imported pandas as pd, so over here I need to write as pd dot underscore underscore version underscore underscore. Okay. So here it gave us the version. So basically this means that we have successfully, okay, it has shown the version. So this means we have successfully imported pandas, right? Now I'm writing a code through which I'm creating a very small data set for us to play around with. Okay, do not worry about the code. We will also, this will get cleared once we do file handling in Python. Okay, so since we haven't discussed it till now, I'm just writing the data set and creating it. Okay, so now once we have created, so student.csv has been created. Now our data set is ready. Now, how do we pull that data set? For that, we write, you can write df. So basically df stands for data frame. Okay, you do not, you can type in anything. You can write it as a is equal to, you can write it as anything, but I usually prefer df. So pd dot read underscore csv. Since it is a csv file, we type in read underscore csv, and in double quotes, sorry, my bad, students.csv. Okay, so pd.read underscore csv is the syntax to read the csv file and give this value to the variable, which is df. So df has been loaded with the data that I just created. Do not worry about this. We will this will get cleared once we deal file handling in Python. Okay, so right now we are only concerned with the data and how pandas is used. Okay, so now df has been created, a data frame has been created. Now let's look at df.head. What is this head? Head is a function through which you can pull the top 1, 2, 3, 4, and 5 rows of any data set. Okay, so df.head prints out the top 5 rows of the data frame. Now df.info, this df.info summarizes your data. It gives you the total so what df dot, so this is a general practice to print out df.head and df.info once you get the data. Okay, so df.head obviously gives us the top 5 rows, and df.info, it gives us different column values and its information. So basically we have 3 columns: name, hours studied, and score, right? So this has given as the column names as name, hours studies, and score. Now this non-null count is the number of actual values that are there in that particular column. So 5 non-null, 5 non-null, 5 non-null. So basically these all 5 rows, 5 values are not null. And the data type that we already discussed, string and int64. Name, it is str, which means string. For hours studied, it is int64. So what do you mean by 64? Int, we can understand, these are whole numbers. 64 is the bits of memory used to store these values. Okay, you need not get into very much of okay. Now, so this also gives us the data types of all the columns. So the first one, name, being a string, obviously makes sense because it's text name. Now hours studied is int64. Basically it is an integer values, and these are all integer values. Yes, and score is also int64, and score is also integer values, has integer values. So this df.info gives us a basic idea of what each individual columns are. Okay, now that we understood what d or dot head and dot info does, let's see. Let's say I want a particular column from the data frame. Okay, so how do we do that? We have different columns with the name of a name, R studied, and score. Now, if I want, let's say the score column, we get the score column. Okay, if we want the name column, we get all the values in the name column. Okay, this is how we pull up the columns from a particular data set. Now let's say if I want average of all the scores. If I want average of all the scores, how do we do that? So for that, dot if I want highest score, we do dot max rent lowest score. Now, what this does is it is giving us the mean of that particular column, which is the score. It will also give the maximum score. DF score dot max will give us the maximum score, which is obviously 88. And min DF score dot min gives us the minimum score in this score column. Okay, we can now also create new columns using the already existing columns. What? Yes. So let's say you want to find out the efficiency of a student. Let's say he has scored 100 out of 100, but he studied only 10 minutes. And another student who has studied for 24 hours and he scored 99 out of 100. So who will be most efficient? Obviously, the student who has studied just for 10 minutes and scored 100 out of 100. So that's what we want to find out. Let's say the new column name is efficiency. So how will we find out the efficiency? For that, we will divide the score with hours studied. Yes. See, now we have created another column with the name of efficiency by dividing the score with the total hours he has studied. Okay. This will give us the efficiency of each student. Now we have created the column name as efficiency by dividing the scores, each score with its corresponding hours studied. Okay. By doing that, we created a new column and we fed all these values into that column. Okay. Now, let's say you want to sort these values based on the efficiency. What do I mean by that? So let's say I want to have the highest efficiency student at the top of the row and the lowest efficiency student at the bottom of the rows. So how will we do that? For that, we have a built-in function dot sort underscore values. Efficiency as equal to. Now what happened is, see, ascending is equal to false. Okay. If we had kept is equal to true, then the reverse would have happened. Now what happened over here is the highest efficiency student, that was Meena, came at the top of the row, and the lowest efficiency Karan came at the bottom. So this is how we sort the values in a given data set. Okay, so in this video, we played around with print, we played around with variables, we played around with ifs and else statements, we played around with the lists. We also learned about for loops, and as well as we also created a function, a very basic function, but function no less. And then we loaded a data using pandas. We did dot head and dot info, and we also calculated average, maximum, minimum, and we also created a new column using already existing columns. Okay, so for today, I think this is enough. Tomorrow, we are going to go one step deeper than this. Okay, so if you have any doubts, please feel free to drop a comment. Next video, we'll go one level deeper where we will discuss about lists, dictionaries, and tuples before going into pandas and numpy. Okay, now I hope this video helped you, and if you have any further doubts, please feel free to drop a comment. We'll meet you in the next video. Goodbye.